So today we're going to be learning about linear equations with variables on both sides. What you guys will be learning today will be how to add to both sides of an equation, how to subtract from both sides of an equation, how to multiply both sides of an equation, dividing, and then we will identify equations with no solutions, with one solution, or with infinitely many solutions. And it's important to understand these methods to use when solving these equations because these equations have variables on both sides of the equation. So we need to learn how to isolate um, the variables by using these types of functions. And so we're going to go through some examples right now. Um, we will, let's see, we're going to do this. Here we go. All right. So the first equation that we have where it's asking us to solve for z, and the equation is negative 54 minus 9z equals 6 plus z. All right. Now, I know this might look a little confusing to y'all because typically when we're doing math, there aren't really any letters involved, but this is actually very, very easy. All we have to do is we have to isolate or move all the z's onto one side of the equation and then all of the other numbers to the other side of the equation. So for example, here on the left side, we can start on the left side. It says negative 54 minus 9z. So what we would have to do here to get rid of the 9z from the left side, we'd have to add 9z to both sides. So we add 9z over here, and we add 9z on this side, on the right side as well. So when we add it, negative 9z plus 9z, that cancels out, and it leaves us with 0. So excuse me. So that comes out to 0, but then it leaves us with negative 54 on the left side. So this is negative 54 equals 6. The 6 remains the same. And then we have z plus 9z. Z plus 9z equals 10z. Oh, excuse me. Equals 10z. So now this equation looks a little bit more easy to do. So now all we have to do is, since we have all the z's on one side, we have to get all of the other numbers, all the other numbers to the other side. So what we'd have to do from this point on is subtract both sides by 6. So we subtract 6 from here, 6 from here. So 6 minus 6, as it did up here with the 9z and 9z, it cancels out. And then over here we have negative 54 minus 6, and that equals negative 60. So now we have negative 60 equals 10z. Now the rest of this is pretty easy. Now we have negative 60 equals 10z. So we can't add, we can't subtract, we can't multiply. Now we have to get z by itself because in the beginning the equation was asking us to solve for z. So what we would do here is we would divide by the number that's in front of z on both sides. So we divide this side by 10 and negative 60 by 10. All right. And so when we divide that, 10z over 10 is just z, so that leaves us with just z. But on this left side, we have negative 60 over 10. Now it's important to remember that we have a negative sign, meaning that we're going to have a negative answer on the left side. So we can do negative 60 divided by 10, that equals negative 6. And we're left on the right side with z. So that's your answer right there. We now know what z stands for. We solved for z. Z equals negative 6. And that's your answer for that one. Okay. We're going to do one or two more examples. So let's see. The next equation would be 2x plus 19 equals negative 6 plus 7x. Perfect. So as we did in the previous problem, we're going to be doing the same things here. So we have to isolate the x and isolate the other variables. So here we would start off by what? By subtracting 2x from both sides. So we subtract 2x from there and 2x from here. When we subtract 2x from the left side, they cancel out because 2x minus 2x is 0. And then when we do it from the right side, 7x minus 2 equals 5x. So then we are left with 19 equals negative 6 plus 5x. All right. And then, as we did in the previous problem as well, we have all the x's on one side by itself. Now we have to get the other variables on the left side by itself. So in this situation, since we have a negative 6, we have to add both sides by 6. Okay. So when we add negative 6x, negative 6 plus 6, it's 0, so they cancel out. And over here, 19 plus 6, we're left with 25. And over here on the right side, we're left with equals 5x. Again, we're to that simpler part of the equation, so all we would have to do from this point is we can't add, can't subtract, can't multiply, so what we have to do to both sides to get x by itself is divide by 5. On the right side, the 5's cancel out, and then we are left with 25 over 5, and that leaves us with x equals 5. Okay. One more, final one. Last equation says we're solving for x, so we have, solve for x, 4x minus 3 equals 2 plus 3x. All right. As we said before, we have to isolate the x's on one side and then, isolate the other variables on the other side. Now, one of the things that I forgot to mention, which I now see that it's relevant in this scenario, is we want to, when isolating the variable x or whatever variable you're isolating, we want to make sure that we try to keep it as positive as possible. And what I mean by that is if we can avoid having a negative variable, we should definitely avoid it, because in the end, it'll just make everything a lot easier. So for example, here it says 4x minus 3 equals 2 plus 3x. Now I could subtract 4x from both sides. That would cancel out the 4x on the left, leaving me with negative 3. But if I were to subtract 4x from the right side, I would be left with negative x. And now that's not a big problem. Like, we can still work with that. But it's much easier if we were to subtract 3x from both sides, because then we're left with a positive x. So we'll see that right here. So as I said, we'll have to subtract 3x from both sides. Subtract 3x and 3x. 3x minus 3x cancels out. We're left on the right side with 2. On this left side, we have 4x minus 3x, so we're left with 1x, or just x. X minus 3 equals 2. And then from here, we're going to add 3 to both sides. Okay, add 3, add 3. So when we add negative 3 plus 3, it cancels out. Then we're left with x on the left side. So x equals 2 plus 3, and that's 5. And that's that.